Hey everyone, welcome back to another math lesson. Today we're going to wrap up the unit for our quadratic equations by doing lesson 5, interpreting the discriminant. Okay, so let's get started. Recall the quadratic formula. We have x is equal to negative b plus minus the square root of b squared minus 4ac, all being divided by 2a. Well, the discriminant is b squared minus 4ac. That's the discriminant. Okay, so the discriminant is used to determine if an equation has no real roots, so it's negative, exactly one root, so the discriminant is 0. 2 real roots, that's where you have a positive discriminant, or you have rational roots, where the perfect square, where the discriminant is a perfect square. Okay. One thing that it does not tell you, it does not actually solve the equation for you. Okay, so it doesn't actually tell you where they are, or like if you have roots, where they are, like where they should be, right? This only tells you these 4 things. It doesn't solve the question for you. You still need to solve, okay? This just provides you with a better shortcut, or a bit of a shortcut, I should say. So number of roots of a quadratic equation. So in the quadratic equation, x squared plus bx plus c is equal to 0. If the discriminant is greater than 0, 2 real roots exist. If the discriminant is exactly 0, you have 1 root. If it's less than 0, you have no roots. Okay, let's do a couple examples. Example 1. Without solving, determine if the equation 9x squared minus 6x plus 1 equals 0 has 1, 2, or no real roots. So if you're going to do that, you need to use the discriminant. Okay, so let's do that. It is b squared minus 4ac. B and c and a. So b squared is going to be negative 6 squared minus 4 times 9 times 1. Okay, so let's see what this equals. So negative 6 squared is 36, and we're going to minus 4 times 9 times 1, which is also 36, so this is equal to 0. Now, when it equals to 0, we have exactly 1 root. So when it equals 0, we have 1 root. Example 2. Given the following discriminant values, determine the nature of the roots. We have b squared minus 4ac is equal to 20. Okay, so knowing that it equals 20, okay, we can say that there are 2 real roots. Because your b squared minus 4ac is greater than 0. Done. B squared minus 4ac is equal to negative 42. Because it equals to negative 42, we have no real roots. Because our b squared minus 4ac is less than 0. Okay. And for the last one, c, b squared minus 4ac is equal to 49. We will have 2 rational roots. We will have 2 rational roots. Because the root of 49 is equal to 7, positive or negative 7. There you go. So we have 2 rational roots. Because 49 is a perfect square. Example 3, last example. Determine the values for k, for which it is 2x squared plus 7x plus k is equal to 0 has no real roots. Okay. So what we're going to do is, again, use the discriminant. So it's going to be b squared minus 4ac. And this is going to be a, b, and k is going to be c. And since it has no real roots, it has to be less than 0. Okay. So b squared, so that's 7 squared minus 4 times 2 times k needs to be less than 0. So that means we have 49 minus 8k needs to be less than 0. Which means that if we were to move the 49 over, that means that negative 8k needs to be less than negative 49, which means that k needs to be greater than, because when you divide by a negative, your inequality switches. So k needs to be greater than 49/8. That is your final answer. Well, that is it for today's lesson on the discriminant. I hope you enjoyed it. Remember, when it comes to math, keep calm and show your work.